Hello Tech World, this is TechThoughts, and welcome to this special TechThoughts video series focused on learning PowerShell. This is an operationally designed video series that aims to get you ramped up in using PowerShell quickly. This is video 13 in the series, PowerShell Modules. As always, if you prefer written documentation, the corresponding article for this topic can be found on the TechThoughts.info blog, which I've linked in the description below. Let's go ahead and get started. I'm going to be demoing a lot of code in this episode. Don't forget that all of the code examples are available on the Learn PowerShell GitHub repository for easy reference. You'll find a link in the description below. In previous episodes, we covered PowerShell scripts and PowerShell functions, where we began to create solutions and solve problems using PowerShell. It's common to stay at this stage for quite a while as you experiment and get better with PowerShell. But as you continue in your PowerShell journey, you will eventually find that you want to enhance the capabilities of PowerShell through the use of PowerShell modules. Additionally, you may want to share something you create with others. To effectively do either, you'll need an understanding of how to work with PowerShell modules. A PowerShell module is just structured PowerShell code that can be easily reused. Let's get a better understanding of these structured components that make up a PowerShell module. Here I have a script, and note the PS1 extension. And inside this script, I have an array declared, and it gets loaded with some custom PowerShell objects that contain information about the various episodes in the Learn PowerShell series. So here we see that we're loading episode 1, and it contains information about the blog link, YouTube link, and GitHub link. And we have a custom PowerShell object for each episode in the series. I'm going to come back up here and collapse this region, which contains all of these custom objects. And notice down below in the main section that I do have a function here called get learn PowerShell info, which is going to enable the user to go ahead and run this commandlet and get some information about various episodes in the Learn PowerShell series. So I'm going to go ahead and load this entire script into memory with Control A and F8 on my keyboard. And that's going to load the entire contents of that script into memory. And because we have that now, I can go ahead and run this particular function, get learn PowerShell info. And I can specify, for example, an episode number of 12. And notice down here that we get some information back from that custom object that contains information about episode 12, which is managing cloud with PowerShell. We're not covering PowerShell functions or logic in this episode, as I've covered those topics previously. You can go back and check out those episodes if you need a quick refresher. Okay, so why isn't this PS1 script good enough? It functions clearly and enables the capabilities that we want. Well, it's just not very efficient from a code sharing perspective. The script has to be shared with someone. They have to save it to their file system and then load the script into memory like we just did. And there's no clean way to source new versions of the script if it's updated or if bug fixes are made. It's also difficult for your code to take a formal dependency on a script like this. What I want to show now is that we can convert this script into a PowerShell module file by changing the extension to PSM1. And note that I've already done that, and you see the PSM1 file over here. This PSM1 file is exactly the same as the script that I just showcased. It has literally just had its extension changed to .psm1. This module file is the minimum requirement for a working PowerShell module. Because this is now a PSM1, I can perform actions with it that were not previously available to me. So I'm going to go ahead and terminate this console, which will remove that script that we previously loaded out of memory by starting a new console. So I went ahead and deleted that. It's going to ask me if I want to restart a session. I'm going to say yes. And now we'll launch a fresh integrated console. I'm going to change to the directory that contains the PSM1 file. And what I'm going to do now is I'm going to run import module against the Learn PowerShell PSM1. And I'm going to go ahead and click enter. So because we didn't get any errors, that means that the module successfully imported. And again, all we did was run import-module against the PSM1 file. And again, that's just a script that we changed the extension to PSM1, which is now enabling us to import using the import-module. So what is this doing for us? Well, now we can run git module against learn PowerShell, which is the name of the module that we just import. And that's picking that up from the name of the module here. And notice that we execute that we do see that a module has been loaded inside of memory. And notice that we have the exported function that we had specified in this particular PSM1 file, the get-learn PowerShell info function. If we had 20 or 30 functions in this PSM1, a user of this module could now explore each and run help and engage our code like a reusable tool set. And because we have this in a module construct, we can see which commands are associated with this particular module. But notice that while this works, it lacks certain capabilities. For instance, note in the example, the module has a version of 0.0. This is because the module file, the PSM1, does not have the ability to provide details such as the module version. This is why most module authors include a PowerShell Module Manifest. In fact, it's a requirement if you want to publish a module to a repository. It's extremely easy to create a new module manifest because PowerShell contains native commandlets to do that. And I'll go ahead and demonstrate that now. I'm going to click Control-N on my keyboard and open up a new tab of PowerShell here, and Control-tilde on my keyboard to stash this window down. And I'll go ahead and run the command new-module manifest. And all we have to do is provide a path parameter. I'll take it right here in the default location that we're already in, and we'll call this learn PowerShell.psd1. And a PSD1 extension indicates a module manifest file. The name of the manifest file needs to be the same as the name of your module. And we'll go ahead and click F8 on the keyboard. And notice over here on the left that we now have a new learn PowerShell.psd1. A module manifest is just a file that contains a hash table of keys and values. These keys and values make up the metadata of your PowerShell module, and this metadata provides a lot of detail about your module. The new -module manifest command went ahead and generated a randomized GUID for our particular module, so this can be tracked in a repository such as the PowerShell Gallery. It populated the author of this module, taking the default user that we ran this command as. And you can come through each of these different values and populate it with information that's applicable to your module. All of this metadata isn't just informational though. Changes here can have a significant impact on how your module operates. For instance, you can control which version of PowerShell your module will run on. And you can also specify required modules that will be installed if your module has dependencies, and much more. You can consult the documentation on how to write a PowerShell module manifest as it details what each of these keys is for and when to use them. You'll find a link on the TechThoughts.info blog. I'm going to go ahead and close this example one that we generated here. And I'm going to go ahead and delete that. I've previously run that new module manifest command, and I've already populated the PSD1 with some information about the Learn PowerShell module that we're creating here as an example. And so notice here that I've put my author name, company name is TechThoughts, and I've written a description about what the module is going to do, so on and so forth. Through the magic of editing, I wanted to cover one particular commandlet that I neglected to mention in the first recording of this, and that is the test module manifest command. And so as you're editing your manifest file, to make sure that you don't enter any type of syntax errors or enter some kind of construct that's not permitted in the manifest, it's a good idea to occasionally run the test module manifest command against your PSD1 file to ensure it's still valid. And so you can execute this using F8 on the keyboard. And so if it returns this instead of an error, that means that your manifest file is valid and can be published to a repository. So if I list the contents of this directory, notice that we do have our PSM1 file, which contains the raw logic and information and functionality of our particular module. And we also have the PSD1 file that's populated with the metadata of our module. And if we import the PSD1 file, note, not the PSM1, we're importing the manifest file, that if we run a git module against learn PowerShell, that we now have a versioned PowerShell module as shown here. And this reflects the manifest information that we populated in the PSD1. Now, if we make updates to our module, the module manifest version can be incremented and we can release new versions of this module. Now that we've covered the basics of PowerShell module components, let's dive into finding, evaluating, and installing PowerShell modules. PowerShell modules are sourced from a repository, the most popular being the PowerShell Gallery public repository. And at the time of this recording, you can see there are over 10,000 unique module packages that are available for download. We can show what repositories that PowerShell is configured to use by running the git repository commandlet. So here we have git-ps repository. I'll run that with F8 on my keyboard. And notice that by default, PowerShell is configured to use the PowerShell Gallery, indicated here with PSGallery. If we run this and pipe that to format-list and star, again running with F8, we can see that the PowerShell Gallery is just a NuGet package management provider. And because we are defaulted to utilizing this, we'll be able to use commands like find module, install module, and save module, which will be able to interact with the PowerShell Gallery by default. So we'll start off with a find module, and we can provide that a tag is a great way to search for PowerShell modules on the gallery. And if you wanted your code to be able to do something, for example, with Telegram, which is a chat client, you could come in here and provide it the Telegram tag and see if the PowerShell Gallery has any modules that have Telegram capability. Here we see that returned one result, which is Poshgram. You can, of course, pipe this to format list as well and retrieve some additional information about that particular module. So here we see we get a lot more information back, including the project URI, so we could go visit and check it out on GitHub. We can see who authored the module, what version it's on, a description about the module, so on and so forth. If I wanted to install this module, I would simply run install-module, provide it the name. We saw that as Poshgram. And we could scope this, and we could scope it either to all users so that all users would have access to this module, or we could scope the install to just this current user. And so only this current user that I'm logged in as would have access to this particular module. I'll go ahead and scope it to the current user, and I'm going to go run this install-module using F8 on my keyboard. Notice that I'm getting a prompt about an untrusted repository, and it's asking me to confirm if I would like to install this module from the PowerShell Gallery. I'll go ahead and say yes. And the install module handles everything for you. It went out and reached to the PowerShell Gallery, downloaded and installed that module onto this particular system. The reason that we got that prompt is, notice if we run git ps repository again, that currently the PowerShell Gallery is by default an untrusted repository. You can adjust this in the configuration settings of your PowerShell repository and elect to set the PowerShell Gallery as a trusted source if you desire. It is possible to register additional repositories using the register PS repository commandlet. Check out the TechThoughts.info blog for additional information, as this can be used to register things like private repositories or internal repositories for your particular enterprise. PowerShell modules can also be installed manually. The PSD1 and PSM1 files simply need to be placed in a folder in the environment PSModulePath. This is a reserved variable that contains the paths that PowerShell will look in to natively discover PowerShell modules. Notice if I click F8 on my keyboard, this lists out a couple of directories. And these are the directories that PowerShell is going to check to see if it can find particular PowerShell modules. Notice that if I start typing in the send-telegram text message command, that went ahead and auto-completed. And I'm getting IntelliSense for the bot token, the chat ID, and the message that I want to send. The reason that PowerShell is able to auto-source and auto-complete for this IntelliSense for this commandlet is because it is checking to see if the send telegram text message command is available in one of these locations. And again, it's getting that from the environment PSModulePath variable. I'm going to go ahead and kill this terminal again and start with a fresh session. And note that in this session, because we have not manually imported the module that we've created as an example, that we do not get the git learn PowerShell auto-completion, and PowerShell is not aware that that function exists on the system. And so what we can do is, again, we'll evaluate the environment PSModulePath command. And what we need to do is place the PSD1 and the PSM1 files that we previously created into one of these locations to manually install this. We could place the PSD1 and PSM1 in the C program files PowerShell modules location. We could also place it in the documents-PowerShell-modules location. And so that's what I'll elect to do. So what we'll do is we'll come in here into Documents PowerShell Modules, and I'll create a new folder. And it needs to be the name of the module that we created. So this is going to be Learn PowerShell. And now that I have that, what I can do is I can copy in the files that we previously created, the PSD1 and the PSM1, into that location. Now that the manifest file and the module file are inside of this location, which again is being sourced by the environment PSModulePath, if I type in git-learn PowerShell, I'm now getting auto completion, because when I clicked tab on my keyboard, PowerShell went ahead and scanned through everything in the environment PSModulePath to see if it could find a module that contained that particular function. So this is how you can manually install a module on your system. Note that because we installed this module in this particular fashion, that we won't be able to do things like use update module to update this from the gallery moving forward. And so once you have taken a manual approach to a module install on your system, you will need to continue to interact with it in a manual fashion. If you wanted to uninstall this in a manual fashion, it would be as simple as coming into the modules location and deleting this particular folder. And that module is now deleted from the system. Sometimes you might want to evaluate a PowerShell module without installing it. And this can be accomplished using save-module. This is going to ask us for some very similar information, and we'll provide it a module name, like Poshgram. And because we're doing a save, we also need to provide it a path. And so we'll put it in ceval. And if we run this command, what's going to happen is it's going to go out to the PowerShell Gallery, because that's our default repository, pull down the Poshgram file, and save it to the c-eval location. So I'll go ahead and run this using F8. And if we visit that location on the file system, notice that it has downloaded this particular module. And now what we can start doing is we can start evaluating the contents of this particular module. So I could, for example, drag this PSM1 file into VS Code, and I could start evaluating and inspecting this particular logic to make sure that it does what I think it does prior to getting it installed on my machine. Because this is in a location that is not part of the environment PSModulePath, your system will not be able to auto-source from this location. But of course, you can navigate to this location. So we'll change directory to that save path, so ceval. And because if I list out the contents of this, it contains a PSD1, we could obviously import the module manually here from this location. And that would allow us to access and evaluate and test different functions inside of this module without actually installing it on our system. So save module is a great function to know. Okay, so wrapping up with a final example, let's publish this Learn PowerShell module so that people around the world can utilize it and learn more about the Learn PowerShell series using PowerShell. In order to publish a module to the PowerShell Gallery, you will need to sign in with an account that's generally tied to your Microsoft account. And once you're logged in, you'll have access to an API key, which will allow you to publish your modules to the PowerShell Gallery and share them with users around the world. There is documentation for how to create a PowerShell Gallery account, recommended best practices for utilizing your PowerShell Gallery account, and you can again find this link on the TechThoughts.info blog. In order to get this module published, what we're going to utilize is the publish-module commandlet. And in order for the publish-module commandlet to be able to run, this particular commandlet needs to be able to source the module on our system. And as we previously discussed, in order for PowerShell to be able to source a module, it has to be inside of the environment PSModulePath. So I need to make sure that my module is located inside of a location that is sourced by the environment PSModulePath. And so I'm going to come in here again and create a folder that matches the name of my module, Learn PowerShell. And because my module manifest file has a module version of 0.70, I'm going to include that version here in a subfolder 0.70. And so notice up here that we are going to a path that is included in the environment PSModulePath. Our folder is named the same as our module name, and we have the version number being specified here. I'm going to navigate into that, and I'm going to include the PSD1 and PSM1 files that we drafted previously. Now that these are in this location, the publish-module command is going to be able to source our module version from this particular location. And we're going to specify a name. It needs to match what is inside of our manifest. And so this is going to be Learn PowerShell. And now we need to specify our NuGet API key. Again, you're going to be retrieving that from your PowerShell Gallery account. We're going to specify the repository that we're going to be publishing this to, which of course is going to be the PSGallery. And we're going to make sure that we specify the exact version that we want to publish out, which is going to be the required version of 0.7.0. And so let's quickly review this. We're going to be using publish-module, which is going to be able to source the Learn PowerShell module because we placed it inside of a location that is sourceable by our environment PSModulePath. And because it has access to this, it's going to be able to utilize our NuGet API key, which we got from our PowerShell Gallery account, and publish this particular module and module manifest to the PowerShell Gallery. And we're going to be publishing the required version of 0.70. I'm going to go ahead and run this with F8 on my keyboard. And this is utilizing the permissions of my API key to publish that PSD1 file and PSM1 file to the PowerShell Gallery. And success. And because this has now been published to the gallery, you watching this video can run the find module command and specify the name Learn PowerShell. We see that the 0.70 version has been published and is available in the gallery. And it has the description and information that was previously entered into our PSD1 manifest file. And so now you can practice at home using save module, install module, and get access to this particular basic module and explore its capabilities on your own device. Now that you have a grasp on the fundamentals of a PowerShell module, let's go check out some source code of a popular published module on the gallery today. And so this is the GitHub link for the Postgram PowerShell module, which adds Telegram capabilities to PowerShell. Now, looking at this, you're probably thinking, hey, wait a second. There's a lot more going on here than a simple PSD1 manifest and a PSM1 module file. And you're right. Many module authors integrate continuous integration and continuous deployment practices into their module development efforts. This enables capabilities such as automated tests, formatting checks, help generation, and combining functions together to build the project for publication. But come up here and take a look into the source structure, and at its heart, every module still just has the basic components that we just covered, a PSD1 and a PSM1. We didn't need any of this extra tooling to publish our basic module to the gallery a moment ago, and users from around the world can still engage it. That said, there are a lot of benefits to adding CI/CD capabilities to your module creation process, and we'll be covering advanced PowerShell module building in a later episode. Make sure to subscribe to be notified when that content becomes available. Don't forget that all of this information is available in written format on the TechThoughts.info blog, and if you found this video helpful, go ahead and click that like button and subscribe for more TechThoughts videos.